4 habits of highly effective AIs. Okay, so what really makes one AI smarter than another? I mean, you'd think it's all about how big it is, right? Or the mountains of data it's fed. But what if the secret is something else entirely?
Think about it. We're always so focused on whether an AI gets the right answer. Did it pass the test? What was its accuracy? But this whole explainer hinges on a different kind of mind-bending idea. What if the secret to an AI getting smarter isn't about knowing the right answer, but about thinking in the right way?
So, to dig into this, researchers set up a little face-off between two AI models, Qwen and Llama. Now, on paper, these two look like twins. They're basically the same size, they were trained on the exact same stuff. You'd expect them to perform, well, pretty much identically.
Yeah, not even close. When they put them to the test on this math puzzle game called Countdown, the difference was, wow, Qwen hits a solid 60% accuracy, but Llama, it's way down there at 30%. That is literally double the performance. So that's the big mystery, right? What in the world is Qwen doing that Llama isn't?
This is where it gets interesting. To solve the puzzle, the researchers had to peer inside the AI's thought process and look for clues. They started hunting for these specific cognitive behaviors, or, as we're calling them, habits.
So the first habit they found is verification. This is basically when the model stops and checks its own work as it goes. You can almost imagine it saying to itself, hang on, let me just check that answer before I move on. It's a simple idea, but it's a super powerful way to catch mistakes early.
Habit number 2, backtracking. This one's all about knowing when to quit. It's the ability to realize, okay, this path I'm on, it's a dead end. And instead of just banging its head against the wall, it stops, backs up, and says, all right, let's try a different approach.
Third up is subgoal setting. You know when you have a huge, complicated problem, you don't just tackle the whole thing at once. You break it down. That's what this is. The AI sets itself a smaller, easier target, like saying, okay, forget the final answer for a second, let's just try to get to a multiple of 10 first.
And the last one, number 4, is backward chaining. This is a pretty slick move. Instead of starting at the beginning and working forwards, the model starts at the end goal and works its way backward. It's like it asks, okay, I need to get to 24. Well, working backward, I know 24 is 8 times 3. How can I get an 8 and the 3?
So let's get back to our two AIs. When the researchers looked at which models were using these habits, they found their smoking gun. I mean, the difference is just night and day. Llama, our underperformer, barely used any of these thinking skills, but Qwen, it was a natural at verification and backtracking. This right here, this was the secret to its success.
All right, so seeing a connection is one thing, but proving it is another. The next logical step was an experiment. Could you actually teach Llama, the struggling AI, how to think like you?
The setup was really clever. They took the Llama model and primed it. All that means is they showed it a handful of examples. But here's the key. Every single example was specifically designed to show these 4 reasoning habits in action. It was like a crash course in effective thinking.
So, did it work? Oh yeah, it worked, big time. After seeing just a few examples of how to verify its work and backtrack from dead ends, Llama's performance skyrocketed from that sad 30% all the way up to 60%. It completely closed the gap with Qwen. This was the proof they needed. You can absolutely teach an AI how to think.
But hold on, because the story doesn't stop there. The researchers decided to push things just a little bit further, and what they found next was honestly the most surprising part of this whole thing.
This discovery led to a really fascinating question. Okay, so we know the AI learns from seeing these good thinking habits, but does it have to see them used in examples that get the perfect, correct answer? Or is it just the thinking process itself that matters?
Okay, get ready for this, because this is the real twist in the story. The researchers did something brilliant. They created a new set of examples for Llama. And in these examples, the AI used all the right thinking habits. You know, verification, backtracking, but it got the final answer wrong. On purpose. And you would think that would completely confuse the model, right? Nope. Unbelievably, Llama still jumped all the way up to 60% accuracy. This is huge. It means the final answer didn't matter at all. The only thing the AI needed to learn was the process, the how of thinking, not the what.
So what does all this mean for the future of AI? Well, it suggests we might need to totally rethink how we educate these models. We need to shift from just feeding them correct answers to actually teaching them the process of reasoning itself.
And here's why that's so important. When the team looked at a typical huge math dataset that AIs train on, something like open web math, they found something pretty alarming. These crucial thinking habits, like verification and backtracking, they're practically non-existent. They make up just a tiny, tiny fraction of the data. We've basically been asking AIs to become expert problem solvers without ever really showing them what good problem solving actually looks like.
So the solution is to fix the curriculum, right? The researchers went back to that giant dataset and carefully curated it. They filtered it to find and amplify all those examples of good reasoning. Then, they used this new, enriched dataset to train Llama from a much earlier stage, basically baking this how-to-think education right into its core.
And that was the final piece of the puzzle. The Llama model trained on this new, specially curated data performed great, right up there with Qwen at 60%. Meanwhile, the Llama trained on the standard, messy data, no improvement. This proves we can systematically build these better reasoning skills into models from the ground up.
So what's the big takeaway here? We're reaching a really exciting point. We're moving past just throwing more and more data at AIs and hoping for the best. We are actually learning how to teach them how to think, how to use the very same cognitive tools that we do. And that leaves us with a pretty thrilling final thought. If we can teach AIs our ways of thinking, what new ways of reasoning will they one day teach us?